thing we're gonna do is, it's important to mention just one more time. The most critical number here, tell me what would be the most critical number? So, what you thought about that? What would be the most critical number right here to solve for this problem? Any ideas?
3,000, 12,000, or no, it's not 12,000, 3,000.
Yes, that's part. 3,000, okay. What's the action is also very important. Actions, and we're gonna find what? Action and then actions. Reaction numbers. The most critical reaction number, this one. This number is wrong right here. AY, AX, and then EY. If that number is wrong, remember, whole thing, 100%, everything might be wrong. 100% chance to be wrong. Alright? Does that make sense? Always double check, triple check your reaction numbers. Yeah, let me show you how you can do this. Then, alright? Do not take a note. Just fully pay attention to the song. Alright? Right after that, after we finish this problem, I'll allow you guys to take a photo or take a note for extra minute. Alright? Just watch. So first thing what I'm gonna do, what we're gonna do is, alright. Pin, alright? Two guys versus these are ruler. Only one support reaction over easy. Alright, let's quickly set up the equation right here. Now there's nothing about this guy, so 0. Alright? So I'm gonna set it as AY, then this EY. Sum the moment at where? At E, right here. Reference. I'm trying to explain very carefully just one more time. After this problem, I'm not going to explain support reaction, alright? Moment E is a reference. Right? Let me begin with this. Obviously, clockwise. Based on our sign promise, let me go away. To make it easy, just give me a second. Let's make it easy. Let's multiply the problems. Okay, forget about this guy. I'll make it easy. Forget about this. Instead, I'm gonna go with 1.2K. It's same. 3K. Alright? So 1.2K negative force time the distance. Simple, very easy, alright? What about this guy? 3K? Obvious clockwise, alright? Clockwise rotation. So based on our sign promise, negative, say negative. Force times the distance, 20. Would that be all? No, one, just one, this one. This is what you want to know. What you're trying to find, which is obviously this direction. Counterclockwise. So plus AY force times the distance 30 equals 0. Therefore, what is it? AY, we got 2.4K. Is that not correct? Yes. K going up. Okay? So from there, by applying this equilibrium for EY plus 2.4K, this is AY, right? Minus 1.2K, where? Right here, from here, from right there. 1.2K, then what about this? Minus 3K equals 0. So EY, we got 1.8K going up. Final answer. Then right after that, there is a way to double check our reaction numbers, alright? Just in less than 3 seconds. Take a 3 seconds for validation. 1.8 go up, add up. 2.4K go up, can you add up? It equals 4.2K going up direction. How many K going down? 4.2K going down. Alright? Which is support. These numbers must be correct. These are support reaction, alright? Then, after this problem, I'm not going to explain the support reaction. Okay? Let's go back. Then we got from previous, we got for this one 1.8K, right? We got 2.4K, all right. Then now we gotta go into each joint, starting from this joint, move to the next, 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 next. No more than 2 members that are unknown are connected at the joint. That joint is out of the candidate, all right? We are not ready. Then quickly, what I'm gonna do is, all right, let's try to find the ratio. Ratio, look at this. 10, it's a 10, 20, make sense? 10, 20, 10, 20, all right? Write it down. Okay, oops. Write it down. The ratio. Here we go. The ratio, write it down. 1, 2. What about this? Can I tell the ratio about this?
1, 1.
Look at it. Yes, 10 feet, 10 feet, 10, 10, all right. It's going to be an easiest ratio ever. What about this? Same ratio, 10 by 10, all right. Then we are ready to apply this MOJ technique. For the each joint, then remember I told you guys last week, as a rule of thumb, easily just try to pick up this one of the free end. Let me start with joint E, all right? Joint E. Look at this. 1.8 Y member, right? Y direction. This is X direction. We're gonna break it by X direction and Y direction. Can you count how many X direction members? 2. How many Y?
1.
So the first equilibrium we're gonna apply is this equilibrium. Must come first. Alright? Bingo. I saying, right, without any hesitation, it must be 1.8K. Why? Equilibrium. Make sense? Just like it. 1.8K. Right? What's next? You still remember? What is the next step? Find ratio for this X member, right? Right, thank you. Based on this 1.8K, these are the Y member, right? Remember, this is the Y, right? Time, the ratio of X, where is it? 2, right? 2. The ratio of Y over 1. Simple, yes. 3.6K. So go back to this. It should be 3.6K. Write it down. Alright? Are we good? So let's move on. We just finished. I told you guys this MOJ is about very patiently we're gonna apply these 2 different equilibrium again and again, alright? Which make this process really boring, time consuming, and then tedious. Alright? Look at this. The next we're gonna apply this one. Alright? Can you look at the screen? Then to help you guys better understand, look at this. Don't look at this, alright? We are right now working on which one? The X. Only look at the X, alright? Don't look at this guy. Don't look at it. This is what we have. 3.6. X and Y. We already got 3.6. The only X. It must be 3.6. Which direction? This direction, from right here. From this direction, which means tension. Alright? 3.6K tension. Alright. Any questions? Basically, we gotta repeat this again and again. Alright? Let me finish it, I'll get back to you. Alright? Then next. Alright? So once we do that, look at it. Looking at this member, look at this member. One end, we got tension, alright? The other end of this must be tension, alright? 100% must be with the same number. What about this guy? Compression, right? Compression. Trying to compress. Say compression. Then the other member must be same. Right? 1.8K. And this is compression. Right? We don't need this joint. Let's move on. Then next, we're gonna move on this joint. Look at this. We got 3.6K from the previous joint A. One member unknown. Alright, 1, 2, 3. Right? No more than 2 unknowns. We are not ready to apply this. So next joint. 1, 2, 3. Alright? There are more than 2 unknown members. Come back to that joint which we are not ready for that joint yet. So we must jump to this joint, alright? Then I'm gonna apply the exactly same technique right here. Look at this. And I'm gonna speed up a little bit, alright? X and Y, X, 2X, how many Y? Alright, so which this suggests we gotta first apply this equilibrium. Then this determines this guy, this member must be the opposite direction, 2.4K. 2.4, make it 0. Alright? 0. Make sense? Now what's next? Tell me, what's next? Ratio. To determine X member, the ratio is given as, look at this. 1. This guy must be 2.4. Same ratio. Alright? Right after that, trying to write it one more time. $2.4K. And we're working on this joint. What's next? So 2.4, this direction. Let's make it 0. There must be another 2.4K in opposite direction. Alright? So, oops. Say this one. 2.4K. Which direction? Is tension. Alright? Then copy and paste put the other name, the other side of the member. Alright? Tension. Just like that. We are done. Then copy and paste this compression, this member compression. Write down compression. Then copy and paste. 2.4. 2.4. We don't need this joint, alright? We don't. So let's change the color. We don't need this. Alright? We don't need this. Then let's move on to this joint F. This is an F, joint F. Alright? Try to answer me. Ethan, how many X members are connected at joint F? I mean, how many unknown X members? So this guy must be 2.4, right? It should take less than 1 second. Very simple. What about about this member? Don't look up. Isolate. 0. Alright, easy. That's how it works. Okay. Look at this. 2.4, write down, K, tension, cut and paste, same thing. Most the same direction, same number, right? Out, 0, right? Look at this, let's move on. The last one, all right? It looks slightly more challenging, but look at it. It's basically, the principle is the same. Just look at it. Make it easy. Let me see. Okay, let's move this down. Right here. Look at this. What's going on? All right. This is 2.4, 3.6. All right. Are we good? Then y, x, and y. Which equilibrium should come first? Please answer me. Which equilibrium? X or y? X. Does that make sense? This guy X. So this member must be coming. Very simple. 1.2K to make it 0. Alright. This is what we did last week. 1.2K. Then it has the easiest ratio, right? 1, 1. Therefore, this guy must be 1.2K. Tension. Alright? Tension. Look at this. Don't look at the X member. Only look at the Y member right here. Y member. 1.2K go up. What about this? 1.2K going down. 0. You see? It's very simple. Right? You just need a little bit of practice once you understand it. It's such easy. Very simple. Right? So, this is compression. 1.2K, make it 0, compression. Right? What about this guy? This is tension, cut and paste. 1.2. Then we can say we don't with this joint. Down, all right? Look at this. We start on this point, right? Last week. So let's go up this way. It's going to be very simple, all right? Look at it. Zoom in. All right. 1.2K, look at this. 1.2 going down, 1.2 going up. Make sense? 1.2 going down, 1.2 going up. What does that mean? Basically, it cancels out each other. 1.2 go down, 1.2 right there go up. Nothing, alright? So we're not gonna care about it. It's 0.
What about that 1.8K going up?
I will explain it. Because that's my question. 1.8 going up. This guy should be 1.8 going down. What about this? 3.6 to make it 0. Alright? Equilibrium, bingo. On the equilibrium, bingo. See? That's asking. Very good. So 1.8, 3.6. Which direction? Trying to compress. Say compression. Alright? Go up. Write down. Carefully cut and paste. Don't switch, alright? Be careful. Then someone will say, someone may be saying 1.8, something like it. Do not switch. Just be careful, alright? So, this to be, right, 1.8, 3.6. Alright. We basically finished going through all the drawings. So let me highlight this guy. Okay, we finished. Then we have one more joint to go. Where is it? The crown. Right here. But basically, the last joint, remember, last joint is our bingo point. We don't have to say bingo. We don't have to calculate anything. All that we solve it. All people, look at this. Okay, let's try to look at it. Yeah, please pay attention to the screen. Right, look at it. 3K. Then head it. 3K, alright, going down, going down. Yeah, 1.2K right here. Can you add up? How many K going down? 1.2. 2 points going up. 1.8 going up. How many K going up? 4.2 going up. Beautiful equilibrium, right? 4.2, another 4.2. Based on our all the previous analysis with the fantastic job, right? What about X? What about X? What is it? 3.6, all right? Is that all? And then 3.6. Then what about it? 2.4 to the left, 1.2 to the left. Can you add up? 3.6, 3.6 to the left, 3.6 to the right. What does that mean? Then time to say bingo. All right? We'll put it on. All right? Without any error. All right? This is how it works. This is method of joy. MOJ. Basically, let's go back. Right? So now, if I explain this, you will understand what I'm talking about. Typically, the process is begin with free body diagram. Then you remember I encourage you guys to develop the huge free body diagram. Why? Easy to trace all the previous answers. It's basically, this technique is very simple, but the least key. If you got what add on the previous joint, then after that joint, everything, whole thing might be messed up. Alright, so you gotta be able to trace very carefully. One simple careless mistake that will have major impact. Alright? Then support reaction, then start at the very end. Alright, apply equilibrium, repeat again and again, again and again. That's it. So, we have one more problem, practice problem here. Right here. Let me give you one more. Can you quickly find the reaction numbers? Reactions. Alright, I'm going to wrap up this lecture with this problem, the last problem for today. And give it a shot, alright? What will be the support reaction? All right, just like this. 10K. I know you need a little more time, but let's just go ahead. 4K and 10K. All right, there is one fatal, really fatal critical mistake. Can anybody please make a quick correction? What's wrong here? The number looks okay. What is wrong here? Well, what is wrong here? Right here. When I said these numbers, it seems okay.
Yeah.
But I told you, you know well.
Not okay. No well. No good.
Any ideas? It's very simple. Trying to understand what's wrong here. Exactly. Thank you. Constant, right? You see? Obviously, what he's saying is, look at this. Pin, how many reactions? Don't forget 6K. It will change everything, whole thing. Alright? Remember, very one simple, very silly, dumb mistake like this 6K, alright? It changes everything. So 6K, thank you. Don't forget it. Say 6. Make sense? Then zoom in. Let me start with this joint. If we do that, trying to understand the ratios. Then 1, 2, 3, 4, 5. All right, we have 5 joints to go for the analysis. And then the last one, 6th joint, we're gonna leverage it for validation to say bingo. All right, let me begin with this. Look at this problem is slightly different from previous slide. Because there's 6K. Look at this. Let me do the same. X, right? X. X and Y. So which one should come first? Obviously this one. Okay? Y member. Y member. So simply, this should be, must be 4K. The ratio. What's the ratio here? I'm trying to find the ratio. You see? Look at it. Yes, 18. It's 18 by 24. 3, 4. All right, make sense? So 3, 4 ratio. So this should be 3K. Well, thank you. Very simple ratio. The ratio is given as 3, right? 4. Let me write down all the members have the same ratio. 3, 4, 3, 4, 3, 4. All right. Go back.
How do you know which direction the arrows are supposed to go?
Okay, good question. How do you know the direction? Look at it. This direction is 100% sure, right? Because of this. After this, going down, this guy should be, look at this, look at the direction. This means this direction must be go this way, alright? If we decide to go up, the direction should be just like this. Look at this direction. Just because of this direction, alright, the X must be going to the way, then defined as compression. Compression. So let me try to answer one more time. This direction determines the direction of this compression. Alright? Compression. Look at this. Compression. Trying to think about this. First assign compression, alright? Random compression. So break it, X and Y. Look at the direction of X and Y. Make sense? If they assign tension direction, just a random tension direction. Look at the direction. It must be go up. Alright? Look at the direction. This is wrong. Because we got this direction 100% determined by this one, right? It must be go this way. Going this way, which is equal to compression. Make sense?
Yes, sir.
Thank you. Thanks for asking. Alright. Then saying this one is compression. Tell me. X member, right? This member. Any volunteer? Nicholas. Can you give it a shot? This member? Sorry, I made it so bad. 6K, is that correct? 6K. He says 6K. Don't forget 3K, alright? Thank you, excellent. This should be 3 plus 6, 9K, 9K. Make sense? If you understand it, this must be 9K. You're good. You're good to go. Alright? Then, say this one must be 9. Tension, alright? We finished with this joint, say compression right here. Compression. Say compression. Look at the flexion. Compression, alright? Compression. Break it by X and Y, alright? X and Y. 3, 4. Okay, let's move on. Okay, now, Ricardo, try to answer, alright? I need your help. Look at this. Now, how many unknowns for that join? 1, 2. So we are ready to apply this technique this time, right? This guy should be, tell me, less than 1 second. Be confident. 9. Is that correct? Yes. What about this guy? Ricardo. Go ahead. Ricardo, go ahead. 0. No. What about this? You're not supposed to know this guy, right? That's called false discrimination. Right? What about this? Tell me. Look at it. 6K going down. 6K going. Is that correct? Yeah. That's how it works. See? Thank you, Ricardo. So this direction going up. Come on. Then 6 tension. All right. Yes. 9K tension. Just like this. Okay. Then what about this joint? Look at this. Look at this. What I'm doing right now. What I'm gonna do is for that joint. 1 member, 2 members, 3 members. We are not ready to apply this technique. So alternatively, let's jump to this joint. Alright? Looks pretty much the same. Okay, 10K. This guy should be must be a 10K, 100%. Alright? 10K. By applying the ratio, 3-4 ratio, 7.5K. Right? Wow, this guy should be, tell me. 7.5K in opposite direction to cancel it out. To stay in equilibrium, 7.5K. Let me remove this. Alright, 7.5K. And then compression. Compression, alright? Am I trying to make my voice differ? Okay. Compression. Look at this. So copy and paste, alright? 10, 7.5, we are almost done. How simple is it? Okay? What about this? We ready for this joint? Yes or no? Tell me yes or no. 1, 2, 9K, 7.5. Yes, we are ready. We are ready. Look at this. We are ready. Then say Y, right? X and Y. Which equilibrium? Boom. X. So X, this number should be, tell me. X, this X should be 1.5. Makes sense? Very simple. I told you. Once you understand it, it becomes just super easy. Just piece of cake. Every state handle is easily. Let me get back to it. Let me finish this. Alright? Now we have 2 more minutes to go. Okay. Set it as 1.5K. Then by applying the ratio, 1.5 is 2K. Yes, 2K. Okay. Then I'm not answering your question. Trying to answer you. Sorry about it. This member must be. Well, we solve for this member 1.5 and 2K. So this member must be. Tell me. Tell me. You said 10K, right? Why? 2K down, 8K down. Very simple. Must be 10K going up, which means tension. Alright? Just like this, say, and go up, tension. This compression. Compression right here. Compression, trying to compress. Just like this. 2, 1.5. 10K. We're almost done. Just give me 1 more minute to go. Then we finish all the bottom. Then let's move up. Let's go up to the second story. Look at this. We got it from my 6K. Look at this. Any volunteer to tell me about this member? We don't have to care about, at this joint, we don't have to care about the Y member, right? Because we have only one unknown, which is X direction. X. 6 to the right, 3 to the right, So total, how many K to the right? 9. 1.5 to the left. This has to be 7.5 to the left. Is that correct? Yes. 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 This time, let's say compression, right? Then last joint, right? Look at this. What's going on? We're going to, let me finish it. I can let it up in 1 minute. All right? Look at this. Let's look at this joint. As our final. Bingo. Look at this. How many K to the left? Look at this. At this joint. Last joint. 7.5 to the left. 7.5 to the right. Bingo. 10K going up. 10K going down. Bingo. Thank you. Okay.